Hi students, this is Mr. Yao. Today we're going to talk about 9.7 where we will learn how to convert between radians and degrees. So first, let's review something we learned before, arc length. To find the arc length, we have this formula. It's the arc length compared to the circumference, which is 2 pi r, and that is the same ratio as the central angle compared to 360 degrees. So first question. Find the length of arc AB. So let's set it up according to the formula. The length of arc AB over 2 pi r is 2 pi, the r is 8, so times 8. That is the same as 60 degrees over 360, which can simplify to be 1/6. And afterwards, we can just do cross multiplication. We can find out our arc length is actually going to be 8.38 centimeter. That's the arc length. Number 2, both the radius and the highlighted arc are 6 inches. Find the angle theta. So this time we're trying to find the measurement of the central angle. So this one. The arc length is given 6 and the circumference 2 pi times 6. That equals to the central angle is theta over 360 degrees. So let's actually not get rid of the pi. Let's keep the pi. So do cross multiplication. That's 12 pi times theta equals to 2160. And we'll actually divide it over and simplify. We're going to get 180 over pi. And that's what theta is. And this is actually the definition of a radian. When the arc length is the same as the radius, that angle is going to be the radian. So let's have a look at the definition. It's just another unit of measure for angles. Just like inches and feet, they're just a measure of length, but they're different. But they're related. So our radian, 1 radian is the measure of the central angle whose arc length is the same as radius of the circle. We just got that is 180 over pi, and if you actually divide, that's going to give you this number, 57.30 degrees. And now we need to know how to change from degree to radian, and how to change from radian to degree. From degree to radian, we just need to multiply by pi over 180. So basically, this is, let's say it's like 30 degrees. Then we have this 30 degree and this degree symbol, they cancel. So our answer would actually be a radian. And if we want to do radian changing to degree, we just need to flip the fraction. So it's 180 over pi. Now let's have a look at 2 more questions. How many radians is in a circle? So we have a circle and the circumference 2 pi r, and r is actually the length that's actually facing a radian, which is about this size. So basically this 2 pi represents the whole circle in radian. And if the whole circle is 2 pi, then the semicircle is going to be pi. So basically 2 pi radian is 360 degrees, pi radian is 180 degrees. So now let's have a look at some questions. Let's convert some degrees into radians first. Multiply by pi over 180. So if you think about it, if you feel like you're going to confuse is a pi over 180 or 180 over pi, well, we're trying to get rid of the degree. So we're going to put degree on the bottom. So in this case, 180 is on the bottom, and that's how we get a radian. So 0 times whatever is 0. And the radian is just RAD. But you don't have to write it. You can. The degree symbol represents its degree. So whenever you don't see the degree symbol, that's got to be the radian. Next, 30 times pi over 180. That's 30 over 180, which is 1/6 pi radian. Next, 60 times pi over 180. That's 60 over 180, which is pi over 3 radian. Next, negative 10 times pi over 180, the negative signs stay there. 10 over 180 simplifies to be 1 over 18 pi. Of course, you can also just write it as pi over 18, that is the same. Next, times pi over 180, that is going to simplify to be 7 pi over 9. That's number 5. Number 6, same thing, times pi over 180. This time, divide the top and the bottom by a 5. That's 61 on the top. 180 divided by 5 is 36. That's number 6. Now let's convert from radian to degree. And these you can clearly see there's no degree symbol, that little circle, so that means they are radian. So in order to get rid of that, we're going to keep the pi on the bottom. You can choose to multiply across. That's going to give you 360 pi over pi, and then you simplify. That's got to be 120. Or you can just do a cross cancel. So the 3 and the 180, that cancels to be a 1 and the 60. The pi just cancels out, so it's 120 degrees. Next, same thing, times 180 over pi. The pi is just gone. 8 divided by 2 is divided by 4 is a 2. 180 divided by 4 is 5. So 45 times 9, that's 105 over 2 degrees. Or you can put in decimal, no rounding, is 202.5 degrees. Next, 180 over pi. The pi is gone. 6 becomes a 1. After divided by 6, 180 becomes a 30. So it's negative 330 degrees. Next, times 180 pi. The pi is gone. Divided by 9, that's 1. Divided by 9, that's 20. So it's 100 degrees. Number 11 times 180 over pi. Pi is gone. Because this pi is basically just on the top, so we can cancel them out. Divided by 18, that's 1. Divided by 18, that's 10. So it's 310 degrees. Next, you're given a degree. So now we need to change it into radian. That means multiply by pi over 180. That's 90 over 1. So cross cancel, that's 1. That's 2. And it's pi half. That's number 12. Number 13. Even though this is a number that doesn't have a pi, well, it doesn't have a degree symbol, so that means still a radian. Degree multiplied by 180 over pi. And that is going to give you 558 over pi. And of course, if you want to divide by pi, and then you just need to round your answer, that's 177.62 degrees. Next, since it's a radian, there's no degree symbol, so multiply by 180 over pi. Pi is gone. 4 is 1, that's 45. So it's basically 45 times 9, which is 405 degrees. Next is degree, so we're going to change it into radian. Pi over 180. And that can simplify to be 187 over 36 pi. Next, 525 is a degree, so times by pi over 180. That's going to simplify to be 35 over 12 pi. Next is radian times by 180 over pi. Pi is gone, that's gone, that's 45. So basically is 19 times 45, which is 855 degrees. Forget the negative sign in front. Next, times 180 over pi. Pi is gone, 18, that's 1 and 10, so 670 degrees. Number 19. Degree, so we want to change into radian times by pi over 180. After simplifying that fraction, that's going to give us 13 over 6 pi. Next, pi over 180 divided by 30, that's 5. Divided by 30, that's 6. So it's negative 5 pi over 6. 21. 180 over pi. Pi is gone. Divided by 12, that's 1. Divided by 12, that is 15. So it's basically 31 times 15, which is 465 degrees. That's number 21. Moving on. Now we have seen some big angles, way bigger than 360, and we have also seen some negative angles. We need to understand where they come from. So let's talk about how angle appears in a Cartesian plane. And a Cartesian plane is just a fancy way of saying our xy coordinate. So in a coordinate system, we have angles. We have something that we call standard position, because we can't just have an angle starting from wherever we want and turn whichever direction we want. We gotta have a standard. So here is the standard position. The vertex of the angle is on the origin. and the angle is measured counterclockwise from the positive x-axis. So the positive x-axis is actually the initial side, and then we start turning counterclockwise. Wherever the angle stops, that is called the terminal side. And that is how we represent an angle. And of course, counterclockwise actually is positive direction, which means if it's clockwise, then we got to get some negative angles. So the angle can turn that way and can turn more. Then we have something called coterminal angles. And here's what it means. So for example, let's say we have this angle right here. But what if I have another angle that actually have the same initial line, so also starting from the positive x-axis, and then it's going to have the same terminal side, but it's not exactly the same angle. So that means, for example, if I actually just turn this much, keep turning, and then I stop right there. You can see the terminal side is still the same side, but they are clearly not the same angle. So coterminal angle means angles that have a common terminal side in standard position. And if you notice, this little part is the first part. Then I just turn an extra 360 degrees. And of course, I can actually turn the other way as well. What if my angle is going this way? Then it still starts. Then it still starts from the standard position, but ends on the same terminal side. And that's a negative angle. So of course, we have a lot more coterminal angles. Their difference is always going to be 360 degrees. So if you find an angle, then you just need to add 360 degrees to get a coterminal angle. Reference angle. The smallest angle that can make from the terminal side of an angle with the x-axis. This angle measure will always be less than 90 degrees, and thus the reference angle will always be in quadrant 1. So you just need to know, so for example, with what we have right here, this angle, the angle that's formed by the terminal side and the x-axis, didn't say positive x-axis, it's just formed by the x-axis. The angle is actually right here. But how do I know how big is that angle? In this case, you can see 180 minus whatever the angle is, that can get us this. But if I actually want to get it into the first quadrant, I just need to reflect it over the y-axis so that I can have this angle the same as whatever this left part is. But that's our reference angle. So first, let's look at some coterminal angles. Find a positive and negative coterminal angle first. Like I said, the difference between all coterminal angles are 360 degrees. So for example, I have my 70 degree right here. Let's say that's 70 degrees. I can just go a full cycle, and then that can give me a coterminal angle, this one. I just turn that much with an extra. I can do 70 degrees plus 360 degrees. That's got to be 430 degrees. But if I keep adding more 360, that's going to remain positive. So in order to find a negative coterminal angle, I just need to subtract 360 degrees. And that's going to give me negative 290. It also says represented in terms of n. The reason we have n is we can turn however many cycles that we want to get however many 360 we want. So in order to actually represent it, that's just going to be 70 degrees plus 360. Because I can get one 360, if I do 2, I just turn 2 more cycles. That's 360 times 2. So that's how we can represent with that. Number 2, we're just adding 360. That's going to give me positive 135. That's a positive coterminal angle. Or I can subtract 360. That's going to give me negative 580. And if I want to represent, that's got to be 30, not 70. That's got to be negative 225 plus 360. Next, if one cycle is how we actually generate coterminal angles of 360 degrees, that means if we change into radian, we just need 2 pi. So in this case, if it's radian, we're adding 2 pi or subtracting 9 pi over 4. If we add 2 pi, well, that's got to be 9 pi over 4 plus 8 over 4 pi, which is going to be 17 over 4 pi. Then if you actually subtract 2 pi, you will see that ends up being 1 over 4 pi. That's still positive, so I gotta subtract another 2 pi, which gives me negative 7 over 4 pi. So these are my actual two answers for coterminal angle. One positive, one negative. And then of course it's 9 pi over 4 plus 2 pi n. We're just adding extra 2 pi or subtracting extra 2 pi. Next, negative 2 over 3 pi plus 2 pi. That's going to give me 4 over 3 pi. I subtract 2 pi. That's going to give me negative 8 over 3 pi. I have a positive and a negative. And of course, I just need to add 2 pi n if I actually want to represent all the coterminal angles in terms of n. Last thing, let's talk about reference angle. Draw the angle measurement in the standard position, and then identify the location of the reference angle and its measure. So number 1, 60 degrees, right here. Just need to draw in first quadrant. So something to be clear. When we actually start from the initial side, which is the positive x direction, that is 0 degrees. Then we go here, that's 90 degrees, that's 180 degrees, keep turning, that's 270 degrees, and then that is 360 degrees. Then we can keep going, 90 can also become 450 degrees, and then just keep going. So that's how the angles are in a coordinate system. And then of course 60 is in between the 0 and 90, so that's about where it is. Since our reference angle needs to be in the first quadrant, well, this angle is already in the first quadrant. That means our reference angle is just 60 degrees. There's nothing else to do. Now let's look at number 3. So the left side, that's 180. 210 is between 180 and 270, so it's actually right there. And this part is basically 30 degrees more than 180 to get to 210. So the angle that's being formed with the x-axis is actually 30 degrees. And that means we want to represent the reference angle as 30 degrees. So here is the reference angle, 30 degrees. And they're basically vertical angle. So if you actually want to find it, you just need to extend the line back into the first quadrant to get your reference angle, which is 30 degrees. Now let's have a look at the radians. So number 2. If you actually put down the angles, we start with 0 and then turn 90 degrees. If you change it into, well, let's actually look at 180. 180 we already know it's pi, and then it goes back to 0, which is 2 pi. So we basically find an angle right in the middle of 0 and pi, and that's got to be pi over 2. And then an angle right in between pi and 2 pi, that's got to be pi over 3 pi over 2. And then of course, if I keep turning after 2 pi, that's now going to be 5 over 2 pi, and then it's going to be 3 pi, and that's going to be 7 over 2 pi. So just keep on going. And 3 pi over 4, that's clearly less than pi, so the angle is actually right here. You can still convert it to degrees so that you know where it is. That converted degree is 135 degrees. So you can see the difference. The angle that's being formed with the x-axis is actually right here. So it's the difference between the 3 pi over 4 compared to pi. So the difference is pi over 4. I just need to represent pi over 4 in the first quadrant. And so I just need to reflect the angle into the first quadrant. So these two angles are the same. And the reference angle is going to be pi over 4. That is number 2. Number 4. So same idea, that's where pi over 2 is. And that is where pi is. So clearly 5 over 6 pi is in the middle. And if you think about it, pi over 2 is basically 3 pi over 6. So I just need to find where it's 4/6 and where it's 5/6, and then this is basically 6/6. So I just need to cut into like 3 parts. So my angle is about here. That is my angle. Which means my reference angle, the angle being formed with the x-axis is right here. So the difference between 5 pi/6 and pi. The difference is going to be pi/6. Since it's in that quadrant, I just need to represent the same angle, so I just reflect over into the first quadrant. This is my reference angle, which is pi/6. Now let's do a few more practice. That's pi/2, and that's pi, and that's pi 3 pi/2. So if you look at this, the angle we actually need is right here on this direction of the axis. So this is the angle that we need. But I still need it to be in the first quadrant because my reference angle cannot be more than 90 degrees. So the angle that's actually formed with the x-axis, this time either side, formed with the x-axis is actually a 90-degree angle. Well, then I just need to reflect over. That's where my reference angle is, and the reference angle is 90 degrees. That's number 5. Number 6, negative 380. That is actually even more than 360, so that means I turned more. So I turned a full cycle. Since it's negative, I'm going clockwise. So that's already 360. That's already 360, but I need more. I need 20 degrees more. So it's about there. That's my angle. But now I need to represent my reference angle. So again, so now I need to represent this angle is about right here. The angle that's formed with the x-axis is right here. So you can see it's a full cycle, which is 360, then a bit more, and that's got to be 20. In order to get it into the first quadrant to represent that same angle, I'm going to reflect over the x-axis. So right here, that is my reference angle, and it's 20 degrees. Next, negative 5 pi/3. So if you think about it, this is 0, and if you go the other way, that's got to be negative pi/2, that's negative pi, that's negative 3 pi/2. And negative 5 pi/3 is actually slightly less than negative 2 pi. So it's around here. And if you actually draw it out, that's already negative 3 pi/2. I just need to turn a bit more because this is 9/6, and if it this is basically 10/6. So I just need to turn slightly more, and it's about there. That's my angle right there. Since it's already in the first quadrant, I just need this part to actually represent my reference angle. And that is basically how much is it, what is it compared to 2 pi, which is pi/3. And that actually is 60 degrees. The reference angle is pi/3. Next, 9 pi/4. So clearly you can see this is actually just 2 pi with an extra 1/4 pi. So I'm going to start drawing my angles. That is 2 pi. I just need more. I just need another pi/4 more. So it's around right there. Since it is in first quadrant, then my reference angle is just this angle with the x-axis. And that is the extra compared to the 2 pi full cycle. The reference angle part is just pi/4.